Hi, let's spend some time going through the script for assignment 3. And so as usual, we're going to start by clearing the working space. Then we're going to set the working directory so that we can load in the data on entrepreneurs. Then we'll load a few libraries, a few packages that we'll need. Then we'll run our usual correct standard error code and turn off scientific notation. We'll read in the data set, so we'll call it EE. Again, a little tip is to call the data set something short, DF, EE. There's no reason to call it a long name because then you'll just be typing or copying and pasting that long name throughout your script. So it's much easier just to call it something really short. Now we're going to create a table of descriptive statistics for a subset of the data. So just year 1. So we have year $=1. And notice also we're going to omit a number of variables. We're going to omit year because if it's year =1, there's no variation in year. We're going to omit the ID. We don't need to know what the mean is of the ID number. We're going to omit the treatment category because it's year 1 and nobody has any treatment category. Treatment's irrelevant for year 1. And then I realized, well, there's other treatment variables there. So I'll just omit all of them by having treat with the asterisk. The asterisk then indicates any other letters that might follow treat. And we'll call this the pre-treatment averages. And there's our 3 variables that we have: shock, remittances, and profits, and 500 observations for each. Then for our next descriptive statistics table, we'll subset to just be year =10, so the double equals sign. We'll omit the year ID and the which treatment variable, and we'll run this. And now we see treatment 3/4, 0.75 of those in the sample, the 500 people in the sample. 3/4 of them are treated. The standard deviation is 0.3. That goes from 0 to 1, obviously. Let's see, this is how many periods they've been treated, I believe. So the average is 3 periods. The mean, 4.5 periods. Then the profits average is 4.67. So we then want to look at the distribution of profits in the last 2 periods, years 9 and 10. So we subset the data to be years 9 and 10. But first we turn the which treat group to a factor variable. And remember, which treat had 4 categories. 1 meant you weren't treated, 2 meant you were treated early, 3 meant you were treated later, and 4 meant you were treated latest. And they all have roughly the same average profits, which are higher than the people who were never treated, right? That's our basic box plot, which is telling us, giving us the distribution of profits for each one of these groups of people in years 9 and 10. So it's a nice visualization of what the data looks like by groups. Now notice here, I did data equals subset. We could have also used the filter command. So we could have rewritten this. I'll just copy the box plot part down here. I'll copy the whole thing down here so you can see how this would go with Dipler. So we start with EE, and then we pipe that into the filter command. And then we're going to just keep year =9 or year =10. So we'll move that over here. And then we're going to pipe that into ggplot. And now we don't have to tell ggplot what the data is anymore because we've already established that in the pipe. So we could put this down here, it'd be a little easier to read. And so if we run this, not surprisingly, we get exactly the same thing that we had. So we can go back to the earlier one. The 2 look exactly the same because, of course, they're doing the same thing. So using the subset command or using the filter command in a pipe give us the same thing. Let's look at the line plot where here I have collapsed the data set using a pipe. So I start with EE. and I pipe it into the group by command. And then I summarize profits to be mean profits and remittance to be mean remittances. And then I assign that back to a data set called profits CLP treat, profits collapsed treat. So I'm going to have the mean of profits and the mean of remittances by year and by what treatment category there are. So if there's 10 years and 4 treatment categories, I'm going to have a data set with 40 observations. And look what I have, a data set with 40 observations. And I look here and I see year 1, treatment group 1, year 1, treatment group 2, year 1, treatment group 3, year 1, treatment group 4, year 2, treatment group 1, year 2, treatment group 2, year 2, treatment group 3, right? And each one of these numbers is the average of the observations. Remember, there's 500 people divided into 4 groups, so 125. I don't remember whether it's even, but let's say it's even 125 people per group per year. So this is the average of those 125 people in that group for that year. I guess that's how it, I don't remember exactly what the data structure is. So that's the mean levels by year, and now we can put them on a plot. So the plot is showing the mean profits over time by treatment group. And we see that group treatment group 1, which are the people who aren't treated, their profits are basically steady over the years, whereas the other treatment groups, treatment group 2, which gets treated early, profits rise early and continue to rise. Treatment group 3, profits rise in year 3 or 4 whenever they get treated and then continue to rise. And treatment group 4 gets treated later, so their profits only rise later and then stay high. We can also, by contrast, look at the remittances of these 4 groups, and we see that their remittances are changing over time and don't seem to be varying with the treatment. Finally, we have our regressions. We estimate 5 regressions per the instructions. And the important thing is that we omit the factor variable coefficients and the constant. So here's how we do the omit. And we can have labels for the explanatory variables, right? So this looks better than having just a label, just the variable name as the label. And we also have, maybe we want to call these different things. Sometimes we'd say, includes fixed effects or whatever. We can put those in here. So that's the script.